Hey everyone, my name is Lukman ALHakim bin Muhammad Azri. My matrix ID is 25124149. This is my video presentation for IMJ 12403 Electrical Engineering under Dr. Latifah Munirah binti Kamaruddin. Today, I'll be talking about AC machines and their real-world applications. Let's go into it. So, AC and DC machines are electrical machines that are literally everywhere in your cars, your home, factories, and industrial systems. They either convert electrical energy into mechanical energy or the way around. For this assignment, I picked an AC machine that most people never think about, but interact with every single day. The machine I chose is the car alternator. Specifically, it's a 3-phase synchronous generator which classifies it as an AC machine. It generates alternating current, and what makes it synchronous is that the rotor spins in sync with the rotating magnetic field. No slip involved, unlike an induction machine. As you can see in the circuit diagram, here the generated 3-phase AC doesn't go directly to the battery. It first passes through a rectifier made of diodes, which converts it to DC before reaching the battery terminal. So, where is it used? Pretty much in every internal combustion engine vehicles, such as cars, trucks, lorries, etc. It sits deep inside the engine compartment, usually mounted to the engine block and driven by a serpentine belt connected to the crankshaft. It's running every single time your engine is on. The alternator's job is to supply electrical power to everything in the car while the engine is running, such as your headlights, air conditioning, infotainment systems, sensors, and most critically, it continuously recharges the car's battery. Without it, the battery would drain within minutes and the car would just die. It won't even start. Now, let's look at the main components. The rotor is the rotating part. It carries the field winding and creates the rotating magnetic field when energized. The stator is the stationary outer winding where the EMF is induced and the 3-phase AC voltage is generated. The rectifier sits at the rear and uses diodes to convert that AC output into DC. The pulley is what connects the alternator to the engine belt. The voltage regulator controls how much current goes to the rotor field winding, keeping output stable. And then you have the brush holder, cooling fan, and front and rear brackets, handling contact, thermal management, and the physical structure respectively. Now, here's how it all starts. When you turn the ignition on, battery sends DC voltage through the brushes to the rotor field winding, which excites it and creates a magnetic field. The engine then mechanically spins the rotor via the belt. Once it's spinning, you've got a rotating magnetic field inside the stator, and from there, the machine takes over. This is where Faraday's law of electromagnetic induction comes in. The rotating magnetic field from the rotor cuts through the stator windings, inducing an EMF and producing 3-phase AC voltage. The frequency and speed relationship is described by this formula. Synchronous speed equals 120 times the electrical frequency divided by this number of poles. So, the faster the engine spins, the higher the output frequency. That AC voltage then hits the rectifier, gets converted to DC voltage, and that DC is what charges the battery and powers all the car electrical systems. Therefore, mechanical energy is in, usable DC electrical energy out. So, why is the alternator the right machine for this? 3 main reasons. First, it's efficient across a wide RPM range, even when the car is just idling. Second, it's compact with a high power output relative to its size. Third, the voltage regulator ensures the stable DC output, regardless of how fast the engine is running, so high RPM won't fry your electronics. It is also highly reliable, low maintenance, and cost-effective to manufacture, which is why it's the standard choice across virtually all vehicles. On the downside, compared to the traditional DC generators, it only natively generates AC voltage, so it needs the rectifier stage. The circuitry is more complex, and it can't charge a completely dead battery on its own, since it needs initial excitation from the battery to start generating. So, to wrap it up, the car alternator is a great real-world example of a 3-phase synchronous generator, showing how AC machine principles directly enable the technology we rely on every day. Thanks for watching!